Hi lads, in this video I'm going to go through the use of Loci. So basically a locus is the path followed by a point while obeying certain conditions. So what I'm saying there is basically, if I have a circle here, I have my centre point there. The distance from the centre out to here is the exact same as out to there, out to there, out to there, out to there, etc. So we're saying that all the points along that circle on the outside are all the exact same distance away from the very centre. And that's what a locus basically is. It's a path followed by a point. So the condition it's following here is that the locus is always a set distance from this point here. So in this first question or construction we're going to look at is, we want to find the centre of a circle that is going to be a distance from this line GH here and this chord AB. So we want to find a circle that is going to come in contact with this line GH and this chord AB. So it'll pass through that chord and it'll also touch off that line GH there. So we want to find a locus which is going to be a set of points that will pass through that centre of the circle. First thing we can do is, because it's a chord, we can bisect it. So if I take my compass and bisect that line AB there, I know from previous construction methods, if I bisect a chord, the centre lies along the bisector there. So bisecting that there, the centre is going to lie along that line there. So somewhere along that line is going to be the centre of our circle. The centre of the circle, we know, is always going to be equal distances from this line GH and also points A and B, because they're points on the circumference of the circle. So I'm just going to focus on A. I'm just going to use A as my example. So the first thing I'm going to do is, I'm going to find a point or points that is going to be 20 mil away from A and 20 mil away from GH. So the first thing I'm going to do is, I'm going to draw a line that is always going to be 20 mil away from the line GH. So I'll just take a line perpendicular here, and what I'll do is, I'll mark off 20 mil there. So I know that this line I've drawn here is always 20 mil away from GH. Now I want to find a point or points that are always going to be 20 mil away from A. So I take my radius there, and swing an arc there. That's 20 mil away from there, and that's 20 mil away from there. So what I'm saying is, the distance from here to here, so let's let focus first. So I'm basically saying is, the distance from here to here is 20 mil, and the distance from here to here is also 20 mil. Next thing I'm going to do is, I'm going to increase that distance now. I'm going to set it as a distance as 30 mil. So I want to mark off an additional 10 mil onto this. So I'm going to draw a line that's now 30 mil away from GH. And also, I'm going to swing an arc that's 30 mil away from A. I get a point here and there. I can see now that that's starting to pass through my centre. So what I'll do is, I'll add one more here just to give a bit of space in between. So 20 mil is too far there, so it's too much of a gap to draw a freehand curve there. So I'm going to set it to about 15 mil. So I'm going to go 15 mil away from here. And I'm going to go 15 mil away from A. So the reason why we're always drawing arcs as well from A is that the only way we can measure 15 mil away from a point is by swinging an arc, just like the circle. Say that was a radius 15, that would be a radius 15, that's a radius 15, that's a radius 15. I'm going to get a point here and there. And the reason why I'm going to stop there, as you'll see, I'm going to draw my curve first. You can see with that curve, that's a locus. And remember, we already said that a locus is the path followed by a point while being certain conditions. The conditions we set out was that we were trying to find a series of points that were equal distances from A and equal distances from the line GH, because we wanted to find the center of our circle that's going to be drawn. So if I just use a colour to show, the distance from A to there, that distance there is the exact same as that distance there. So what we're saying is this point here is equal distances from the line GH, and it's also an equal distance from A to there. If I pick another one, let's go green this time. If I pick, say, this point here, that distance from here to here is the exact same as that distance from there to there. So they're equal at all times. That distance is the same as that, so they're equal distances away at all times. The reason why I've stopped here as well is we already determined that the chord there, when we bisect it, it passes through the centre. And we can see from our locus we already have a point far enough out here that when we draw our curve, our locus passes through it, and that gives us our centre. So all we need to do now is actually draw in our circle. We take that line GH, the tangent, so if I go perpendicular from this point here, that's going to give me my radius there. And also I can take this from there to there as my radius as well. All I need to do now is stretch it out to that distance there and draw in my circle. And you'll see that it'll pass through that line, it'll pass through B, and it passes through A as well. There you can see there, passes through point B there, A there, and it touches our line at that point there as well. So we've proven there using the locus that we can fit the circle in between points A and B and also touching off our line GH there. So that's one example of where a locus is needed to find the centre of something that isn't given. In the next one we're told that we need to find the position of a circle that is going to come in contact with point P and also hit off these two lines here, so in between that angle. First thing we can do is we can bisect the angle at the base, because we know if a circle is going to fit in between the angle, the centre of it is going to lie along the middle of the angle there in between. So that angle there is equal to that angle there. So somewhere along that line is going to be the centre of our circle. So we don't know where to stop yet. The other bit of information we have is it touches off point P. So this time we're going to use point P as our reference to help us. So the first thing I'm going to do is I'm going to use the ground as my other line. So similar to this one here, having a line and a point, this time I'm going to take this line here and this point. So the first thing I'm going to do is I'm going to take a line up here, just so I can measure my heights. So I'm going to be going parallel to that line at all times. First thing I'll do is I'll set maybe 10 mil. So that point there, that line is always going to be 10 mil away from this line here. Now what I need to do is take a radius of 10, because I want to find my 2 points that are also 10 mil away from P. So I have a point here and a point there. Next thing I'm going to do is set 20. So I'm going to go 20 mil away. So I'm going 20 mil away from the line. Now I want to go 20 mil away from the point. Once again, swinging from P. I'll just do it on this side. There's no need for me to do it on that side there, as the centre is going to be passing through along this way here. It's going to fit inside this side here. That's still not going to intersect with the line, so I need to go 30 mil. So if I go 30 mil, I want to go 30 mil away from that line there, so that's always 30 mil away. Now I want to go 30 mil away from point P, so I can always go equal distances. You can see now that passes over it, and I draw my locus going all the way. You can see there my locus of points cuts across my centre. That's going to give me the centre excuse me, of my circle. Take that down there, shows me it's going to come in contact here, and just using slide and set squares then to find the tangent point on the opposite side. It's going to occur just there, and it's also going to come in contact with point P. So to show you in colour once again before I draw on the circle, what I'm saying is, for example, this point on the curve here, that's equal distances from that line there, and it's also the same distance from that point P. So there are two equal distances. Just showing once again another one, I'm saying that the distance from that green line is the exact same as that distance there at all times. So now I can draw in my circle as a result to fit in between. So you can see there, it's in contact with that line there, this line here, and it's also passing through point P. So that's another example of how we can use a locus to find the centre point of our circle.